Now, taking this form, c cosine square root of 6ti plus I times d sine square root of 6t, we can let c and d be arbitrary complex numbers. These solutions work even if c and d are complex. So we let c equal c1 plus c2i, and we let d equal d1 plus d2i. Then our solution becomes y of t. Now we're going to substitute c1 plus c2 for c here. Our solution is going to become c1 plus c2i times the cosine of the square root of 6t plus, I'm going to put the I at the end here, we'd go d1 plus d2i multiplied by, I'll put the I here, I times the sine of the square root of 6t, and this equals what? We multiply this out and collect our terms and separate the result into real and imaginary parts. I'm not going to go through all the details of that, but we're going to have c1 times the cosine, and we're going to have d2i times the sine. Now I times I being -1, we should be able to see pretty easily that we get c1 cosine of the square root of 6t plus I squared times d2 sine square root of 6t. I squared is -1, so this is going to give us minus d2 sine of the square root of 6t. And those are going to be our real terms. And we're going to then have imaginary terms, c2i multiplied by the cosine of the square root of 6t becomes I times c2 cosine square root of 6t, and then we're going to have d1 times I sine square root of 6t. The I we'll leave out here, we'll let it distribute, and we have d2 sine square root of 6t, and we see that we have a real and an imaginary part to the solution. This real part is a linear combination of a cosine and a sine of the square root of 6t, and without going into the details of the trigonometric identities, you should know enough about trigonometric identities. You might need to review a little bit of basic trigonometry, but the trigonometric identities tell us that this linear combination of the cosine and the sine of the square root of 6t could be written in the form alpha times the cosine of square root of 6t plus phi, where the constants c1 and d2 basically are replaced by constants alpha and phi, and the values of alpha and phi can be determined from c1 and d2 using trigonometric identities. Now we can do a similar thing with the imaginary. We have another linear combination of the sine and the cosine, and that could be written as I times alpha cosine of the square root of 6t, and I'm missing a left parenthesis here, plus phi. where this alpha and phi can take any values depending on the values we have for C2 and D2. Again, I'm not going to go into a lot of detail on that, except of course to say that this alpha and this alpha don't necessarily have the same values. We got completely different constants over here on the imaginary part as opposed to the real part. So I'm going to subscript these. Alpha 1, phi 1 for the real part. Alpha 2, phi 2 for the imaginary part. Now let's just review where we are before we draw any more conclusions. This function and this function, therefore this function, therefore this function are solutions to the equation y double prime equals negative 6y. Now I've gone ahead and written in these two solutions. C cosine squared of 6t plus d sine squared of 6t, where C and d can be understood to be real, imaginary, or complex constants, or y of t equals alpha 1 times the cosine squared of 6t plus phi 1 plus I times alpha 2 cosine with a phi 2 here. Where in this case the alpha 1 and phi 1 are real. Okay, so C and D are in general complex. Alpha 1 and alpha 2 and phi 1 and phi 2 are real. So I could say